Apple over the years have created some of the most well-known products there are, but some are a bit less well-known and successful. But which one of them is the least well-known? Is it the Apple Newton? Well, no, probably not. I mean, it was unsuccessful, but it's pretty well known. I mean, they even had a go at it on The Simpsons. Is it the Apple Pippin, Apple's failed games console? No, probably not. There's a lot of videos on that on YouTube. Is it the Apple Free? No, we've all heard of that one, surely. Maybe the Apple Lisa. Again, commercially unsuccessful, but a fair few people have heard of it. Now, I think Apple's probably least known product is the one I'm about to show you now. Don't worry, I've not taken leave of my senses. I do actually know that's a SunSpark workstation. No, that's not the product itself, it's what's running on that SunSpark workstation that's all Apple-y. Yes, welcome to the video on the Mac application environment. Apple's very own Apple emulator for Solaris and HP-UX. Now at this point in the video you might be thinking, a Mac emulator? Well, there's loads of them, so what? Well, this one's a little bit different, apart from the fact that it's written by Apple themselves, and actually has a licensed copy of the OS, unlike virtually every other Mac emulator out there. It's also a little bit special in how it works, in that it doesn't just have any old version of the Mac OS. It has its own special one, based around System 7. And what makes it so special, I hear you cry? Well, obviously I don't, because it's the internet and this is not a two-way medium. But let's say that I did. Well, instead of the whole operating system ROM being written targeting Motorola 68000, this one's, well, targeting Spark. So whenever an application makes a call to the operating system, instead of that being in 68000 that the Spark has to emulate, well, that API call has been replaced with a block of Spark code. The other clever thing about this one is, it doesn't work like a lot of emulators where you just have a file you use as like a fake hard drive and a regular Apple filing system's put on that. Instead, the operating system's able to access the Unix file system beneath it. Now this is not only great for speed, but also interoperability between the Solaris side of things and the Mac side of things. A file on the hard disk can be opened either in a Mac application or in a Solaris application. There's basically no difference. Now so far we've mainly talked about how the Mac application environment avoids running 68000 code. So now it's probably time we turn to the 68000 emulator itself. After all, that's what all the applications are written in. Now here Apple went for a technique that was pretty modern for the time. Instead of running like a traditional emulator where it just steps through every 68000 call one by one, and each time it encounters one it decides which equivalent set of Spark calls it's going to make, this one does it by compiling blocks of 68000 instructions in one go. This allows it to optimize somewhat, and also avoids the need to interpret the same instruction more than once, because once one block of 68000 instructions has been compiled, well, it stays compiled, and next time the emulator wants to run it, it just runs the compiled version. This means the longer an application runs, the more it speeds up, basically, and becomes less of a burden on the Spark system. Now all these optimizations really do make for a really smooth experience. My memories of this back in the day was that, well, applications of the Mac application environment ran about as smoothly as they did on an actual Mac. I mean, part of this is the fact that a Spark processor is a heck of a lot more powerful than the Motorola 68040. I mean, it should be. Each CPU costs somewhat more than an entire Mac. These clever software techniques also really did make quite a difference. The other reason this feels quite smooth in comparison to an actual Mac has got something to do with, well, it's a flaw in the way the Mac does what it does. It's all to do with how the designers of the Mac OS decided to make API calls work between the application and operating system. Now the Motorola 68000 has a handy little feature. There are a set of instructions in the 68000 that are basically illegal instructions that can be trapped by a software routine. Now Apple's OS designers decided to take advantage of this. When an application wants to call the operating system, it calls one of these illegal instructions. The CPU then jumps to the relevant trap handler for it. However, there's a distinct disadvantage with doing it this way, in that a 68000 when it encounters an illegal instruction will flush both its data and instruction cache, and then jump to the routine and run it. Problem with this is a modern processor really does depend on its cache for, well, being able to run at a decent speed, because the speed of memory relative to cache speed is really slow. So flushing out your cache, you really take a performance hit doing it, and if an application calls the API a lot, then you really are, well, killing the performance of the machine. Of course, our emulated 68000, when it encounters an illegal instruction, doesn't have any effect whatsoever on the actual cache of the CPU that it's running on. This means all the trap code and everything that runs after it basically runs at full speed as if the cache was fully functioning. Now this will be the bit of the video where I jump to a machine and show you around the Mac application environment, and that's certainly my plan, only, well, this happened. Yep, that's the sound of the scuzzy hard drive in my Spark station dying. Great. So I figured, oh well, never mind. I mean, I can get this thing running in an emulator so I can at least show it to you. And, I could just explain what had happened. And, yeah, it wouldn't be as realistic as running it on the machine. You wouldn't get an idea of speed, but you'd at least see it running, right? Well, no, that plan didn't work either, because while the Mac application environment works perfectly on an actual Sun, on this emulated Sun, yeah, kernel panicked. Turns out I'm not the only person having that problem. Yep, there's a flaw in the emulator. So, on to plan C. Now, as luck would have it, I happen to have a SCSI to SD board lying around. And by lying around, I mean I was intending to use it for an entirely different project that's obviously not going to happen now, because I'm stealing it for this Sun machine. And of course, first I'm going to have to mount it in my Sun machine. So I'm going to have to make it some little feet it can sit on, so time to spend a couple of quality minutes with the 3D printer. And then melt these little brass inserts into them so I can screw something into it, and then finally fit the board in my Sun. Yep, that'll fit well enough. Now I actually need to get this thing set up. So I'll pop a Solaris CD image on the first bit of the SD card, set that up as a CD drive, set up the rest of it as hard drive, then install Solaris on the machine, and then finally, I've got to the point where you can show you the Mac application environment. So you ready? Behold, here it is in all its glory. As you can see, it basically just consists of one window. And in that window runs Finder and every other Mac app that we happen to launch from it. Now you can watch me noodle around in this for a few seconds as I launch an app here. Ooh, so happy. But as you can see, it's really a pretty decent speed. Here's me moving around in the File Explorer. There you go, we're moving through Unix files. All very exciting. This thing also adds some Apple network services to Solaris for us. We suddenly gain the ability to speak Apple Talk, so we can talk to any other Apple Talk devices for printing and file sharing. We've also got a Novell client, which is, pretty handy actually. When the Mac application environment starts up, it's black and white. But you may have noticed how suddenly all my windows change colour, that, well, it can do more than 2 colours. You can in fact go all the way up to 24-bit colour depths, although it should be said that most Sun workstations at the time were either monochrome or 8-bit colour. The Mac application environment also had a couple of control panel settings for configuring the emulator. Here you can see us changing what our keyboard map is. Here are our general preferences. And in this window we can just crank up the amount of memory available to the Mac. Man, would this been a handy feature with real Macs. You'll notice that there's a limit there of 300 odd meg. Now that limit's not the amount of memory available in the Sun machine, there's actually 512 meg in the machine itself. I'm guessing that's some form of operating system limit. Now I should probably say something about how I've done the screen capture for this one, because you are actually seeing some artifacts from the way in which I've done this that don't show up on the actual machine itself. Originally I was just planning on using a VGA capture device for this, but when I plugged the whole lot up, yeah, the VGA capture device did not like the output of the Sun. Not entirely sure why that is, but some machines aren't exactly VGA native. You have to use a converter cable from its video connector to VGA, so maybe there's something a little bit odd in there. So I went with plan 2. I'd use software capture from the X server and get it that way. That plan did not go well either. Yeah, capture software for Solaris 2.6 is not the greatest, and the video format looks a bit weird and wrong and overly blurred, and yeah, early 90s video capture, So, plan 3. I'd just log into this thing remotely via SSH, fire effects and capture it on my machine. Nope, that didn't work either. Turns out the Mac application environment doesn't transport that way. It really wants a local X server. I suspect this may be a licensing thing. I seem to remember from when I used this many years ago, you could license it to run on your workstation or license it to run remotely on X workstations, and I'm guessing the license I've got for this is just for the local workstation. Okay, so 4th capture method it is then. I set myself up a VNCX server on there, and recorded the output of the client on my own workstation. This way I actually got a fairly decent video capture of the thing. However, it does have one artifact, which is this weird, slow window tile drawing thing. That doesn't actually happen on the Spark station itself, it actually draws the window pretty much instantaneously. That's just a sort of side effect of using VNC, I'm afraid. And as I had no plan 5, I just kind of had to go with it. Right, let's get a copy of Top running on this so you can see what's happening on the Unix side of this at the same time as we're using the Mac application environment. Now, as you can see, the process MAE is right at the top, which is unsurprising, as I'm not really running anything else on this workstation at the moment. As you can see, when MAE gets really busy, we top out at about 25% CPU usage. Now you might be thinking, wow, that means it's got bags of CPU left. Well, not quite, because this is a 4-processor machine, so 25% is one entire CPU glued at 100%. However, as you can see, if an application runs for a while, well, that percentage starts to drop. It drops a reasonable amount. Now this is where this recompiling technique they've used for the 68000 emulation is really kicking in. Whenever the 68000 emulator encounters a block of code it's already run before, instead of recompiling it again, well, it uses the compiled version it used the last time round, so it's got a chunk of Spark code it can basically just, well, run. This means the longer we sit in an application, the more of it we see, the less load it ends up putting on the Spark. Now of course some applications will never drop in CPU load. Take Stuffit Expander for example. Stuffit is a decompression utility. As you can see here, its CPU load never falls below 25%, or one entire CPU. This is not the emulator failing to cross-compile 68000 instructions properly. This comes down to the fact that decompression is essentially a CPU-bound task. It'll take as many CPU cycles as it can get. So rather than our application over time using less CPU, we will see its throughput increase. Now you may be wondering to yourself, is the performance I've seen of the Mac application environment in this video realistic? Well, this is all being done on a Spark Station 10, which is a fairly typical Sun workstation about the time that Mac application environment was released. Originally Spark Station 10 came out in 1992, but it did hang around for quite a while, so you would have found plenty of them hanging around in universities in the mid-90s. Now this one's a little bit more high-end than most, but not hugely so. You'd have easily found machines of this sort of spec in universities at this time. In terms of market, where Apple sold most copies of this was into higher education institutions. This is especially true in the States, where Apple had a pretty good share of the educational market anyway. So the Mac application environment meant that universities could make use of site-wide licenses for software that they already had and run it on their Spark stations and their HPUX machines. This use of pre-existing site-wide licenses was a pretty strong reason for universities to make use of this. In fact, the university is where I first encountered the Mac application environment. Now this is the third and final version of the Mac application environment. When they released version 3, Apple produced a white paper along with it. This largely explains how the Mac application environment works, but also sets out their goals for the future at the very end, for version 4, the version we never got, where they said they were looking towards letting us run PowerPC binaries in this as well. After all, version 3 got released after the Power Mac. Sadly, or at least for the Mac application environment, Steve Jobs returned to Apple and basically killed almost every product they had, and started to phase in a new line of machines and eventually a new operating system. Which was very good news for Apple users, less good news for Solaris users that wanted to run Apple software. Now you may well be thinking this is all very fascinating, but this wasn't exactly a significant part of Apple history now, was it? And you're right, the Mac application environment never really sold in significant numbers, and a pretty small percentage of the Apple user base were Solaris and HPUX users making use of this. But I would argue this thing's slightly more important than you think it is. Because between the first and third versions of this being released, Apple released the Power Mac. Now you might be wondering, what the heck does this have to do with the Power Mac? I mean, it couldn't even run Power Mac software. Well, the Power Mac could run 68000 software, and Apple really needed it to bridge the world of the original Mac and their Power Mac, and, well, the Mac application environment is where they figured out how to do this. It gave them all the experience they needed in emulating 68000 code, and how to do it at a pretty decent speed too. This meant when you bought your Power Mac, or your original 68000 Mac software, well, it just kinda worked. Which is what at this point in time Apple really needed, because if they'd produced a new system that wasn't compatible with the old one, it wouldn't have sold very well. Well, that just about wraps it up for this video. If you made it all the way through to the end, I'd like to say thank you very much for watching. If you enjoyed it, why not click the like button? If you really disliked it, there's also a button for that. And if you really liked it, why not subscribe to this channel, as subscriptions make a really big difference to a channel of this size.